only got a few, won't take very long to go through them. Some of you will know some of this already, or maybe most of this already, but I thought it's really useful just to make sure everyone knows where we're coming from with ExCALIBUR. So ExCALIBUR, you probably know what it stands for: Exascale Computing Algorithms and Infrastructures Benefiting UK Research. It's our big exascale program, nearly £46 million. The money comes from the Strategic Priorities Fund, so it's SPF funded. And the project's actually jointly run by UKRI with the Met Office. The Met Office is working quite closely with the UK Atomic Energy Authority as well, and there's about 17.5 million of the 46 million is for their side of the science. There's 4.5 million for a hardware enabling software program, which I'm chairing, and I'll tell you a bit more about that in a minute as well. And most of the rest of the money, so the bulk of the money, is actually being administered by EPSRC, and that's funding the exascale software programs, of which the one that you're part of is part of that program. So that's what's happening overall. It's a 5-year initiative. We're already in year 1, so about halfway through year 1. There's a whole bunch of stuff that's being funded through ExCALIBUR. Some of it's knowledge integration, some of it's identifying high priority use cases. Obviously your area of B-class is one of those. It's to look for the emerging requirements of high performance algorithms. So as we try and get to exascale, we're expecting many things might change. We really want to look for those emerging requirements and not just assume everything is business as usual. There's lots of cross-cutting research, and also there's this idea of doing proof of concept hardware, and that's what's led to the hardware enabling software program within ExCALIBUR that I'm chairing, and that's connected to all of the other activities as well. So that's sort of ExCALIBUR in a nutshell. You probably knew all of that already. The hardware enabling software part that I'm chairing, the idea is we're aiming for exascale here, right? So we're not just aiming for the hardware that we've got today. We're not just considering Archer-type systems, but we're really having to look into the future to try and understand what kind of hardware are we going to have when we're actually going to be running exascale simulations. So the hardware enabling software program is going to be running a whole bunch of prototyping exercises, do this every year, trying to look for kind of the exciting emerging hardware that may end up using to get to exascale. So it's going to be doing that, scanning and building prototype systems, and also it wants to listen to all of these software projects, the kind of stuff that you'll be doing within this program, to hear what your requirements are, what are the things you're finding really difficult, what are the things you really need, and then go looking for emerging technologies that might help solve those problems. So the ExCALIBUR hardware enabling software program, the idea is for it to both inform, so here's the kind of architectures you need to be aware of that you might end up using, and be informed by what your needs are, what your requirements are. We'll go and try and find things that might help. So that's the idea of the hardware enabling software program within ExCALIBUR. We're planning on having partners with industry, public sector, etc. And really what we're talking about here is things that we're trying to solve problems together that are 10 to 1,000 times bigger than we can solve today. We're trying to do them 10 to 1,000 times faster than we can do them today. The kinds of problems within ExCALIBUR that are being considered, they're simulation based or data modeling or data driven. Basically any of these things haven't been narrowed down. From any area of research and innovation, it is a UKRI program, not just EPSRC. This was a little comment from Jeremy about we're interested in exascale velocity, not just exascale volume. Right, so I thought that was quite a good idea. So what's happening is within the ExCALIBUR hardware enabling software, we've got 10% of the budget, so about £4.5 million. We're going to spend about £1 million a year and build prototypes of things that we call pre-commercial, right? So this is not hardware that's just on the regular shopping list today. Things that are probably still in the lab, just starting to emerge. We want to get our hands on those things while they're still in the lab, working with the companies that are developing them, start to build up some experience and knowledge to share with all of the software projects so you know what might be coming, and to give feedback to the companies that are developing those products. So that's the idea. Hopefully that's going to give us a big benefit. This is something the US has done a lot of. We've not tended to do this much in the UK. So for example, consider the Archer program, which I've been very closely involved with the last two procurements. We tend to go and buy whatever is available at the time we're doing the procurement. We don't tend to get involved in helping develop the products before we're ready to buy them. But this is starting to address that, actually starting to get us as a UK science community involved with companies in the earlier stages and actually putting some money on the table to build prototypes and start to do some real co-design for things coming in the future. The thing I want to say on this slide is another really important activity we're starting to ramp up is benchmarking for exascale. Andy Turner, who's on this call, is very core person involved in that effort, and lots of other people involved in that. And that's really starting to think about how should we be benchmarking ready for exascale, given the huge differences that could potentially bring, and there might not be any hardware that we can really target for this for several years yet. So we're having sort of think much more in the future about this. It's quite a different way of us thinking about how to do benchmarking, and we're just starting that activity now, but this is something we'd very much like to connect to your program and get your input to what might make good benchmarks for exascale, and not just production codes, but also things like mini apps and synthetic benchmarks and things like that we can use. So that's what's going on with this hardware enabling software program within ExCALIBUR, which we think should be very closely connected to what you're doing. In terms of the scale of the challenge, just to give you something to think about for the call later on, think about Archer 1. There are not many simulations that use the whole machine today. That's 118,000 cores. That problem is going to be exacerbated with Archer 2 when that comes online later this year, when we've got 750,000 cores, giving you about 28 petaflops. And if you think about an exascale machine, it's about 35 times bigger in terms of performance. So that's millions of cores, potentially tens of millions of cores. It could be, in fact, probably likely to be a heterogeneous machine of some sort. Could be using GPUs, could be using something else, likely to have wide vectors, likely to have accelerators of some sort. So the challenge of efficiently using an exascale machine is going to be significantly larger than using all of Archer 1 today, and we don't do that a lot yet. So we've got a really big challenge coming up to really make use of these machines. Just to quickly cover the sorts of things the US have been doing, it's quite useful to see where they've got to. So they've been running their exascale computing program, ECP, since 2016. There've been several programs before that, so they've been working on this problem for many years. They're spending about $450 million on their exascale software program. That's just on the software, that's not on any hardware. Works out about $56 million a year. That funds between 110 and 160 FTEs. And so remember, our budget's about £45 million for 5 years, just to put that into scale. US's GDP is about 7 to 8 times bigger than ours, if you want to try and do some comparisons. US currently runs about 55 different software projects, and they've got 89 different things they call products, so software outputs from those initiatives. So they've been doing loads of things that we hopefully will be able to learn from, as has Europe, as has Asia, and so on. So the idea with ExCALIBUR in general is to pull the smartest people together from across the UK to realise we're not starting from scratch here. We've already done lots of great work. There's been lots of great work in the US, lots of great work through PRACE and now EuroHPC, lots of great work in Japan, lots of great work all around the world. We really need to build on what everyone else has done and not just reinvent things for the sake of it. It's critical for ExCALIBUR to be a very joined up project. It's not, we can't fund everything from scratch, so we really need to understand all the different software projects, make sure everyone's not reinventing the same wheels over and over again, keep everything joined up to make it efficient. We're going to have to be focused once we figured out what it is we really want to do. We're not big enough to be able to do everything. We're probably going to have to be very creative. That's not necessarily a bad thing. If we had infinite money, we could probably be quite wasteful, but we're going to have to be quite creative to figure out how to get where we want to be from where we are with the funding we got. But all of that said, this is a great opportunity. We've got these £45 million, mostly on software, for the next 5 years to get us to this exciting next generation at Exascale. So we really need to go for that and make the most of it. And there'll be lots of exciting projects like yours doing part of that. And I think that's pretty much everything I wanted to say. So I don't know